what is a graph database? What are the pros and cons of it over a relational database like MySQL or Postgres?
All right. So graph databases sort of fall into two categories. The most popular one are going to be property graphs, things like Neo4j. And then the other sort of category would be the triple stores, or RDF graph databases. So the RDF is a subset of property graphs. So we'll focus our discussion on that. And so these databases are meant to represent the objects and their relationships between each other. And so they're explicitly storing nodes in a graph, and then the edges represent the relationship between the different nodes. And the edges can have labels and attributes the same as the nodes themselves. So the high-level concept of a graph database is not new. This is what basically the codicil model was for COBOL in the late 1960s, and it's just sort of been rebranded as graph system. There's nothing about a graph database. There's nothing about graphs that are special that you couldn't represent in a relational database system. The key difference when you look at the performance benefits of a specialized graph database or relational database really has to do with the query API. Meaning, how do you traverse a graph to run some kind of algorithm, right? To find connected nodes. And if you had to do this in sort of traditional SQL, then it could potentially be multiple round trips between the application and the database server. And those round trips are going to make things slow. Whereas in a graph database, they would have a specialized API that say, do this traversal, and you can do that within a single client request. This has changed, though, in 2023, because now the SQL standard supports property graph queries that allow you to do things that look a lot like Cypher in Neo4j. You can do this all now directly in SQL. There's a bunch of other optimizations you can have in your relational database engine, for example, worst case optimal joins, that allow you to do the efficient graph traversal directly in a relational database system. So it is my opinion that you do not need a specialized graph database system, and in the near future, systems like Postgres and others will be a better choice than any specialized system.
Yeah, and researching this question, I was looking at kind of pros and cons definition, and I kept coming across a graph database is really suited to like a social network use case. And then I was like, so I Googled, what does Facebook use as its internal database? It's like, well, then they must use a graph database. And it said they use MySQL.
Yeah. So Facebook or Meta has probably the world's largest deployment of a MySQL cluster in the world. But the difference is, though, the way they use MySQL would not be, I would not consider as a sort of a true graph database installation. It's the underlying backing store of higher level application or logical semantics. And so there's actually a caching layer that provides a graph API sits above MySQL. And those applications interact with that API rather than getting direct access to run SQL queries on MySQL. So again, there's I suspect that in the case of Facebook, all the traversals of the graphs are done outside of MySQL for that reason, because it's sort of abstracted away from those other parts of the system.
I think I was researching it for the graph database question. And it sounded like graphs are almost just a variant or they fall within NoSQL. Is that correct? Or
yeah, so the NoSQL, like there wasn't like there isn't like there's not like a standards committee says these are NoSQL, these are not NoSQL. So NoSQL when people think NoSQL, MongoDB is what people first think of, and it typically means these like JSON databases or things that look like JSON. But that sort of expanded to include like Redis, which is a key value store, or like the Neo4j, the graph databases. It's basically any database that was built within a 10-year period that says we're not going to do SQL or relational model. Then they got slapped with a NoSQL term. But okay, like key value stores, these things existed since the late 80s. The JSON databases are basically the same thing as XML databases from the 2000s or the object-oriented databases from the 1990s. Again, they just didn't call it NoSQL. There is it's funny, there is actually an Italian database system called NoSQL that it's from like 2000 that predates all of this, like the buzzword.